Hello everyone, I am Safrin. Today we are going to discuss about stack insertion operation. First of all, what is stack? Stack is a linear data structure that organizes data in a specific order following the last in first out principle. That means the last item added to the stack is the first one to be removed. Next, overview of stack. Overview of stack is three steps. First step is LAFO structure and second step is push and pop. Third step is memory management. The first one is LAFO structure. Stack follow last in first out method, where the last element pushed into the stack is the first one to be removed. The next step is push and pop operation. The two primary operations on the stack are push. Push means add an element and pop means remove the top element. Next, memory management. Stack are commonly used to keep track of function calls, control flow and memory location in programming languages. Stack basic operation. Stack basic operations are 5. Push, pop, peek or top, SMT and SPUL. First, push operation. This operation add an element to the top of the stack. For the example, if you push the color red onto the stack, it becomes the top item. The next operation is pop operation. This operation removes the top item from the stack and returns it. For instance, if the top item is yellow, performing a pop will remove yellow and return it. The next operation is peek or top operation. This operation allows you to view the item at the top of the stack without removing it. This is useful for checking what the most recently added item is. The last operation is empty. This operation checks whether the stack is empty, which is important for preventing errors when trying to pop from and stack. Next, detailed explanation of push operation. Inserting elements. First step is allocate memory for the new element to be added to the stack. The second step is store the new element at the top of the stack, updating the stack pointer. The third one is increment the stack pointer to reflect the addition new element. Next, push operation. Push operation. First, here the stack is empty, top element is -1. Now we go insert the orange color. Now the top element becomes 0. Next, inserting the color blue color. Now inserting blue color, the top element becomes 1. Next, insert yellow color. Inserting the yellow color, now the top element becomes 2. Next, insert the pink color. Now the top element becomes 3. Inserting the pale green color, the top element becomes 4. Next, insert blue violet. Now the top element becomes 5. The last color is green color. The top element becomes 6. Then the stack is full. And the syntax and pseudocode for push operation. Syntax: void push int val int nm. Top element, first check the top is overflow or empty. So if condition to check top equal to n, print of overflow, else top equal to top plus 1, stack top equal to val. Pseudocode: function push the stack element. If stack is full, return error top. Stack top equal to element, return success. Thus the program to insert 7 colors in the stack. The first line of the program to initialize the structure. The stack structure has an array item of type char to hold up 7 color names, each up to 9 characters plus a null terminator. An integer top which keeps track of the current top position in the stack. Initialization function. Next one is the function initializes the stack by setting the top variable to -1, indicating that the stack is currently empty. The third, check if stack is full. This function checks if the stack is full by comparing the top variable to max -1 if top is max -1. the stack has reaches its maximum capacity. Fourth one is check if stack is empty. This function checks if the stack is empty by checking if top is -1. If top is -1, the stack has no element. Next to the push operation. Push function adds a color to the stack. If the stack is full, it prints an error message and does not add the color. Otherwise, it increments the top variable and copies the color string to the items array at the new top position. Now next is the pop operation. Pop function removes the color at the top of the stack. If the stack is empty, it prints an error message. Otherwise, it prints the color at the top position and decrement top to remove it from the stack. Function display all 7 colors currently in the stack starting from the top. If the stack is empty, it prints a message indicating that. Lastly, main function. In main function, a stack is initialized and filled with color names. Each color is in the color array is pushed onto the stack. The display function is called to print the stack content. After pushing all colors, finally a loop pops each color from the stack until it's empty. The other one is handling stack overflow scenario. Stack overflow. Stack overflow occurs when an attempt is made to push an element onto a stack that is already at its maximum capacity. The next one is error handling. To handle a stack overflow, the push operation should check the current size of the stack and return an error if the stack is full. Dynamic resizing. Some implementation allows stack to dynamically resize its underlying arrange to accommodate more elements, preventing overflow. The next one is time and complexity of push operation. Time complexity. The time complexity of the push operation is 0, 1 as it only involves updating the stack pointer and adding the new element. And the next one is space complexity. The space complexity of the push operation is also 0, 1 as it only requires a constant amount of additional memory to store the new element. Third one is efficiency. The constant time complexity of a push makes it an efficient operation, allowing for fast insertion of element into the stack. Next one is applications of push operations. First, function calls. The push operation is used to return addresses and function parameters when making function calls. Second one is expression evaluation. Stack are used to evaluate mathematical and logical expression with push operation and storing operands and operators. Undo or redo stack. Stack are used to implement undo and redo functionality in application with the push operation. In conclusion, a stack is powerful data structure characterized by LIFO principle, making it essential for various programming tasks. By understanding the purpose and operations a stack, particularly through the example of inserting 7 colors, we can appreciate it signifies in managing data effectively. Whether it's handling function calls, managing undo action in application, or parsing expression, stacks play a vital role in computer science. By mastering the basic concepts of stack operations, we lay the groundwork for talking more complex algorithms and data structure in the future. Thank you.